we're looking at the Unit 3, Lessons 1 through 4 practice quiz answer key today. The first question is about graphing a log function. So this question would be from section 4 out of, or actually section 3 out of Unit 3. So we're working off the formula for log equations of A times log base B of the quantity in parentheses x minus h, close parentheses, plus k. So the first thing that you want to do for these problems is figure out what are the values for a and b and h and k. And in front of the word log, there's no number, so we can assume the value of a is 1, which is 1 times log. Our base is 2, so that's b. And inside parentheses, we have x minus 2, which means our h value is 2. Whenever you have an h value, that is a shift in the x direction. There is no number at the end of the problem, plus or minus anything, so k is 0. When you work, when you find that your a value is 1 and your b value is more than 1, you're going to need to look at the tables that I gave during this lesson in your notes. You'll see that the y values for b greater than 1 and a equal 1 are negative 1, 0, and 1, and the x values are 1 over b, so 1 over 2, 1, and b. But then we have an x shift of 2, which means we need to add 2 to all our x numbers. So I did a little plus 2 for each of the x values. 2 plus 2 is 4, 1 plus 2 is 3, a half plus 2 is 2.5. So you're graphing the x shifted values and the y values. I plotted them over here, connected them, and made a smooth log curve. For question 2, we're doing the same kind of thing, but we're doing an exponential function this time. The formula for exponential functions is a times b to the x power. If there is anything in the exponent, x plus or minus anything, that would be an h. If there was any number at the end of the problem plus or minus anything, that would be a k. But we don't see anything this time, so all I have is just a is 4 and b is 3. So for exponential functions, this is from the notes on lesson 1 out of unit 3. Your x values are going to be negative 1, 0, and 1. And when a is some value other than 1, your y values are going to be a over b, a, and a times b. So for a divided by b, that would be 4 over 3, which is about 1.3. A is 4, a times b, 4 times 3 is 12. So I'm graphing negative 1 and 4/3. You can see over here on my graph, I'm in my y-scale count by 3s, so 1.3, the 4 divided by 3, is a little bit more than a third of the way between 0 and 3. So it's a little bit more than a third over here. Then we have 0, 4, which would be about here. And then 1, 12 would be up here. Notice how I changed my y-scale, but I didn't change the x-scale because I didn't need to. And you can do that as long as you are clearly labeling each of your axes so that the teacher knows what you're counting by for each axis. Once I had my 3 points, I just connected them with a smooth exponential curve. This problem also asks us to do the domain and the range, which I didn't do on here, but we're going to talk about real quick. The domain, if you remember from that lesson, for an exponential function is always all real numbers. This goes forever to negative x and forever in the positive x direction. The range, if you look at the graph, you can see that this graph is always staying above the x-axis. It gets really close to it on the left end, but it never crosses over it. So the range is all y values greater than 0. For question 3, we got a word problem. It says the initial number of bacteria in a culture is 12,000. The culture doubles each day. We need to write an exponential function to model the population y of the bacteria after x days. And part B, how many bacteria are there after 6 days? So the basic equation that we talked about in the lesson for this, this would have been lesson 2 out of unit 3. Said y equals a times 1 plus r to the t power. Now they say they want us to use x for the days instead of t, so if you use x instead of t, that's perfectly fine. A is your starting amount, r is the rate of growth, t is the time, or for us, x would be the time. Our starting amount was 12,000, and they told us that the bacteria is doubling each day. So if it's doubling, then r has to be 1 because the base doubling means 2. That means this 1 plus r, or r plus 1, I wrote over here r plus 1, the same thing. That number is going to be 2. So if r plus 1 equals 2, that means r is just 1. So our equation is 12,000 times 2 to the t power, or x if you choose to use x instead of t. Part B, how many bacteria are there after 6 days? You just plug 6 in for the time. 2 to the 6th power times 12,000 gives you 768,000 bacteria. Question 4, we have to solve an exponential equation. To do this, again, you're trying to get the two sides to have the same base. They first give us 1 over 4, and I don't really like fractions, so I'm going to go back and call this 4 to the negative 1 power. Anytime you have a negative power, it just flips it down to the denominator. And 64 is 4 to the 3rd power, so I change that. Once the bases match, you're just looking at the exponent. So we have negative 1 times the 2x plus 2, and we have 3 times the x minus 1. We're going to distribute that, move our x's so they're all on one side, move our numbers so they're all on the opposite side. This is just algebra 1 stuff now. Solving for x, we get 1 over 5. Question 5, we've got an inequality, but it's basically the same process as number 4. You're trying to get the same base. This time we're working off the base of 10. If you look at the exponent properties, not exponent property, exponent table, you'll see that 1,000 is 10 to the 3rd. So I'm going to rewrite that as 10 to the 3rd. Now they have the same base. We're going to just look at the exponents. 2x plus 7 is greater than or equal to 3 times x, 3x. We're going to move all our variables to one side, and we get the equation for the inequality. 7 is greater than or equal to x. Alternatively, you could have flipped everything around and said x is less than or equal to 7. It would mean the same thing. Question 6, we're now into lesson 3 and 4. For the back of the page, we need to write an equation in exponential form. We're just moving from log form to exponential form. The way you do that, you find your base, which is 2, to the power y, which is 6, equals the answer x, which is 64. 2 to the 6th equals 64. There's nothing to solve, you're just changing the form. Question 7, we have to evaluate, which means we're solving for what this is equal to. And they just give us log base 8 of 4. You're going to say that's equal to some number, and then put it in exponential form. So when I chose x, so 8 to the x power equals 4. Once you set up this equation, your goal is to get the same base like we did on questions 4 and 5 on the front. And both of these numbers are powers of 2. 8 is 2 to the 3rd, and 4 is 2 to the 2nd. So this should say 2 to the 3rd times x, I forgot to write my x up here, equals 2 to the 2nd. And once the bases match, you just look at the exponent. So we'd have 3x equals 2, solve for x, you get x is 2/3. Question 8 is another word problem. This is one problem that was off the homework that we did in class. It says, an equation for loudness in decibels is L equals 10 times log base 10 of R, where R is the relative intensity of the sound. Sounds that reach levels of 120 decibels or more are painful to humans. What is the relative intensity of 120 decibels? So the relative intensity means we're solving for R. If they give us this number, that's got to be the L, the loudness. So our loudness is 120. We're plugging that in the equation. We're going to divide both sides by 10 first. We get 12 log base 10 of R. We're going to go from log form to exponential form, so that would be 10 to the 12th power equals R, which I have right here. And 10 to the 12th power is just 1 with 12 zeros after it, which is 1 hundreds, thousands, millions, billions, trillion. 1 trillion decibels for the relative intensity. Question 9, solving the equation. So we've got 3x minus 5 equals log base 2 of 1024. And this is log form. First thing we're going to do is go back to exponential form. The base is 2 to the 3x minus 5 power equals 1024. We're going to get these to be the same base. 1024 is 2 to the 10th power. And I don't have that on the exponent table because I don't go that far, but that's something where you would just have to recognize if this is base 2, this also has to be base 2, and just figure out how many times you multiply 2 by itself to get 1024. Once the bases match, we're going to just set the exponents equal to each other. 3x minus 5 equals 10. Solve it with basic algebra 1 skills. You're going to get x equals 5. Question 10, we have log base 3 of x minus 5 equals log base 3 of 3x minus 25. When we worked on these kind of problems in class, we saw that anytime there was a log on each side with the same base, you could just drop the word log. So it's just x minus 5 equals 3x minus 25, and then it's algebra 1 skills from there. And you're going to get x equals 10. For question 11, same process, except we have an inequality now. We're going to drop the logs, so it says x plus 6 is less than 17. Subtract 6 from each side, you get x is less than 11. But remember that logs can't be 0, can't be less than 0, they can't be negative, so you have to also say that x is greater than 0 at the same time. Question 12. An ecologist discovered that the population of a certain endangered species has been doubling every 12 years. When the population reaches 20 times the current level, it may no longer be endangered. Write the logarithmic expression that gives the number of years it will take for the population to reach that level. This is actually a difficult problem that we didn't go over, so the process for this is you're setting the equation up, which is going to be y equals a times log base b of x. The way you figure out a and b and x, what's the rate that the population is growing at? It's been doubling, that's your base, the b value. If it's doubling, that's 2. The time period is the a value. That happens every 12 years, so a is 12. And when the population is 20 times bigger than it currently is, that's the x for this formula, so it's 20. We're just writing the expression, so it's just 12 log base 2 of 20 is equal to y. You don't have to solve it, you just have to set it up. Okay, that's the whole practice quiz for Unit 3, Lessons 1 through